Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into a fascinating post about reviving the defunct Jooki audio player. It's not just a hardware fix, it's a journey into firmware hacking, uncovering hidden exploits, and ultimately, reclaiming control of a forgotten device. Exciting, right?
Absolutely. I'm hooked already. So, this Jooki, it was a popular screen-free audio player for kids, but the company went belly up, leaving many devices unusable. This blog post details how to bring them back to life, essentially.
Precisely. The author meticulously details the Jooki's internal workings. We're talking about reverse engineering the firmware, finding a backdoor, and even achieving code execution. It's a goldmine of technical details.
So what's the hardware like? I'm curious about the components.
The Jooki uses an ESP32 microcontroller, an 8GB SD card with multiple partitions, a speaker, and a battery. The SD card's file system is a fascinating mix of X4 and FAT partitions, each serving a specific purpose. There's a factory partition, a content partition for audio files, and a config partition for settings. It's all very cleverly organized.
And the software. How does the update mechanism work?
It uses Mender, an open-source OTA updater. This is a really smart approach, using a dual partition system for atomic updates and rollbacks. If an update fails, it automatically reverts to the previous version, preventing bricked devices. The configuration is stored in a minder.conference file, and the server used was minder2.muselabs.com. Unfortunately, that server seems to be down now.
So if you could control that server, you could potentially update all Jooki devices? That's a powerful position to be in.
Exactly. A huge security implication. But the author also found some more immediate vulnerabilities. There's an HTTP server with several interesting endpoints. 1/LL acts as a root backdoor, allowing arbitrary command execution. Another, /flags, lets you set various flags that control different aspects of the device's functionality. It's a bit like a hidden control panel.
Whoa! So essentially, you could remotely control these devices through these vulnerabilities?
Yes, but there's more. The heartbeat script, which checks in with my.jooki.rocks, has a critical flaw. It executes any additional code returned by the server, prefixed with #ml_OTA, without any validation. And, even worse, it ignores SSL certificate verification. This is a major security hole.
I see. So an attacker could potentially hijack the DNS and inject malicious code into the devices? That's terrifyingly efficient.
Exactly. The author also mentions other interesting points, like the hard-coded root password in the shadow file and the possibility of modifying the Jooki.conference file through the web interface to add your SSH public key. There's even a way to reprogram the ESP32 to reset the device. It's a complete technical deep dive.
This is incredible. It's a testament to both the ingenuity of the original Jooki design and the resourcefulness of the author in finding these vulnerabilities. But it also highlights the importance of secure coding practices, especially in IoT devices.
Absolutely. This blog post is a valuable lesson in both reverse engineering and security. It shows how seemingly small oversights can lead to significant vulnerabilities. And, it's also a great example of how a community can breathe new life into abandoned technology. Thanks for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the world of Jooki hacking. Goodbye.
Bye-bye.